Welcome back to the Awesome Agents podcast. Today we're talking robots specifically. Hugging Face just dropped LeRobot v0.5.0.
Yeah, this is one I genuinely got excited about. First, humanoid support in the framework, plus some training speedups that are real, not just marketing numbers.
Let's start with the headline. They added the Unitree G1 Humanoid. What does that actually mean in practice?
It's more than just a driver shim. They added full teleoperation support, Mujo co-simulation with accurate G1 dynamics, dataset recording, policy training, and real-time inference.
So it's the whole pipeline, not just we plugged in the hardware.
Right. And the Unitree G1 is notable because it runs around $20,000, which is low enough that academic labs can actually buy one.
That's cheap for a humanoid.
Humanoid cheap, yeah. Pair that with an Apache licensed training framework, and you're meaningfully lowering the barrier.
So the hardware cost stops being the blocker.
For serious labs, yeah. The question becomes software, data, and whether anyone actually has the patience to get the full stack running. The docs assume you know Cyclone DDS networking.
Okay, so let's talk about speed. They claim 10x faster image training NIMI. What happened there?
They fixed data pipeline bottlenecks that had been there since early versions. The training loop was blocking on I/O between environment steps most of the time.
So it wasn't a new algorithm, just fixing what was already broken?
Basically, when your pipeline spends 90% of its time waiting on disk reads, fixing that is a big deal. Video encoding is also 3x faster now from parallel processing.
And there's a new policy model called Pi0-FAST. How's it different from the original Pi0?
The original Pi0 uses diffusion, specifically flow matching, to generate action sequences. Pi0-FAST switches to autoregressive next token prediction, like a language model does.
Is that actually better though?
Faster, definitely OY my 5x faster training. And they compress action tokens by 10x using a trick borrowed from image compression, discrete cosine transform plus byte pair encoding.
Wait, they're using JPEG math on robot actions?
Exactly. It works because action sequences have low frequency structure, similar to images. Most of the information lives in the smooth, slow components.
That's clever. What's the trade-off?
On the hardest benchmark task, Libero 10, Pi0-FAST scores 60. Their average across all tasks is 82.5, but that one compositional task pulls it down noticeably.
So you gain speed but lose some capability on long, complex sequences.
That's the honest read. For shorter manipulation tasks, it looks strong. For multi-step compositional problems, the diffusion approach still has an edge.
There's also something called real-time chunking. What's the problem it's solving?
Chunk-based action policies produce a batch of steps at once, maybe 50 plus steps ahead. When the robot finishes executing that chunk, it has to wait while the next one gets created.
And that pause shows up as a weird hesitation in the robot's movement.
Right. Real-time chunking runs the next chunk generation in the background while the robot is still executing the current one. No pause at the boundary.
And it keeps the motion consistent across the handoff?
It adds a guidance term to the denoising process that keeps the new chunks overlapping steps close to what the robot actually did. Smoother overall.
They also added LoRA fine-tuning for large policies. Why does that matter practically?
Pi0 and small VLA are big models. Full fine-tuning on custom robot tasks is expensive. LoRA lets you adapt a subset of weights at a fraction of the cost. Now it's one pip install.
There are some breaking changes though. Python 3.0 is a hard minimum now, and Transformers v5.
That's going to break CI pipelines still on 3.10 or 3.11, and Transformers v5 creates conflicts with anything pinned to v4. People will need to allocate real time for upgrades.
The paper also got accepted at ICLR 2026.
Which matters for legitimacy in research circles. Academic labs pay attention to what makes it into top venues. It probably helps LeRobot get taken seriously as more than a demo framework.
So where does this leave the project overall?
I think v0.5.0 crosses a line. The infrastructure is solid enough that this is now a real production training pipeline for labs with hardware. Whether the humanoid support becomes a serious research track depends on how many G1 owners are also in the LeRobot community.
And that community just got 50 new contributors in one release cycle.
Growing fast, the open source robotics ecosystem is a lot more interesting than it was a year ago.
That's LeRobot v0.5.0. Thanks for breaking it down, Maya. We'll be back with more from the world of AI agents.